We begin this module at the same place that we began the previous module. We should be familiar now with the rule as applied to independent projects and mutually exclusive projects, and also with the goal of capital budgeting, maximizing the value of the firm by maximizing the NPV of projects that are selected. However, as we saw in the previous module, it's possible for there to be exceptions to the NPV decision rule. The goal of capital budgeting does not change. We still want to maximize the value of the firm by maximizing the NPV of projects selected. But sometimes selecting projects on the basis of NPV doesn't necessarily result in maximization of total NPV. In this module, we turn to the situation with independent projects. The NPV decision rule is that we would normally accept all positive NPV projects. The exception applies when there is insufficient capital to undertake all positive NPV projects under consideration. We begin with an example of the implementation of the standard NPV decision rule. If we have a capital budget of $200 to spend and we have these three investments to choose from, if we use the NPV decision rule, which says that we select projects on the basis of the NPV, which project would we select first? The answer is project B. It has the highest NPV. After we select project B, we find that we've used up the capital available, $200. But we can do better than that. If the amount of capital is limited, then we can maximize total NPV by selecting projects on the basis of their profitability index rather than the NPV. This is the formula for the profitability index, the NPV of the project divided by the amount of money invested in the project. Incidentally, it's possible to calculate a profitability index based on a range of limited resources, and the textbook talks about different kinds of profitability index. But we are only dealing with the profitability index in this subject, where the limiting resource is the amount of capital available. Instead of selecting projects on the basis of their NPV, let's calculate the profitability index of these three projects, rank them from highest PI to lowest, and see what that does to the projects that are selected. So this is the calculation of the PI for project A. The NPV of 70 divided by the investment of 80 gives us a PI of 0.875. Using this formula, calculate the PI of projects B and C. Project B is 100 divided by 200, or 0.5, and project C is 75 divided by 120, or 0.625. We'll now rank them from highest PI to lowest. If we now select projects on the basis of the profitability index, which projects would you undertake before your $200 is exhausted? Going from the top of the list, we would select projects A and C. They use up our entire $200, but by selecting on the basis of PI, total NPV is maximized. We have NPV of $145 instead of $100. Let's do one more example of selecting projects on the basis of PI. Consider these four projects, which are ranked from highest PI to lowest. Again, we would select project A and project C. If we go to the next project on the list, we can't afford it because it'll cost us $200 and we only have $5 left. But we need to look further down the list to see if we can afford additional projects which have a positive NPV. In this case, we can afford to select project D. It fits within our capital budget and gives us an additional $2 of NPV, giving us total NPV of $152.